Alright, so in this video I'm going to show you a piece of script I have written to build kernel on Slackware. So this is a simple although little detailed shell script which I have curated to get the job done, basically to bring down the kernel source from the net, set different configuration parameters, compile it, make it, and then install it in a designated location and making changes to the other script which will affect the boot. Okay, so this is everything related to kernel, custom kernel built on Slackware, and it is a bash script. To heads up to the bash expert or script expert, if you find it ridiculously not so efficient, please pardon my naivete and lack of understanding. You can correct me in the comment section if you want. Okay, so with that heads up go out of the way, let me get into my Emacs. Here is a file I have opened already for you. This is a file. To go through it, first of all, I have declared a bunch of variables on the top of the script. By the way, you will find this particular piece of script in my GitHub repo under the admin script repository. I'll upload this particular script in my GitHub repo called admin script. If you wanted to have a lengthy look at it and try it yourself, you could get it from there. Once this video is complete, I'll upload it there. Okay, so by the time, let me briefly explain you how it does. It's very simple. As per my understanding, I wrote it many years ago and I just modified a little bit just to show you how easily you could do the same thing. Okay, and this script has been there in my system for many years now, with some tweaks here and there. So as I said again, all the scripts expert and bash expert, if you fret, please do let me know your precise fretting point in the comment section so I can correct myself. Okay, enough. So first of all, so I'm trying to get the binaries as a POSIX compliant way, and this I have learned from some expert that command -b, then the binary you are looking for, that's the POSIX compliant way to find out a binary in the system. Then it's a good practice. People say, experts says that you always mention the path of your binary to the variable if you wanted to. So that's what I did. Then I tried to extract the kernel table, which will be in XZ form, or you can adjust this variable according to the, because I know how the kernel table released and what are the extension it has, so it's become easy for me to induct it statically. Okay, you could have easily dynamically find out the extension of compression of that kernel list table if you wanted to and make things complicated. You are free to go ahead and do that. I didn't bother. So the next thing, I hard coded the stuff from my because I'm running this system on this script on my system, so I know the location it could be different to your location, but I think these are the pretty standard location where things reside on a Linux system. So, and you can see I gave the variable name as explicit as possible, so it will be easier to understand what are the variable contains looking at the variable name. Okay, so this location can be different to your machine. And then I do again, this is a script. I have mentioned the URL, did I? Or you should, yes, I have mentioned the secure kernel table. This is a script written by one of the fella who work at Linux Foundation, and this has been hosted in kernel.org. So you can bring down that script, this script is basically to verify the Gpg key of the signer of the kernel tree, especially by Greg, by Linus. Okay, and there is a auto signer key, which is, this script is basically securely download and verify the kernel table from kernel.org. It's a wonderful, nicely written script. Okay, you should get it and you should use it. I told everyone, and I mentioned it many times before in different other platforms, that if something is there better, you should adapt it. Okay, so I highly encourage, you can see this URL. This URL will take you directly where the script is, so you can wget it or curl it from there. It's pretty darn easy. You don't have to sweat enough. Next, again, I'm running my system with UEFI boot. I boot my system from UEFI shell most of the time. If it is not there, there is a other booting mechanism. But I given up on Grub many months ago. Don't get me wrong. Grub is a wonderful booting mechanism or booting platform, but I do not personally need it. All this complexity and bells and whistles and all this stuff. I was looking for something very plain, very simple, and very easily manageable, so I opted for it. Okay, so booting from UEFI shell or some sort of gummy boot which was dead, system deboot or whatever, which is very minimal in a sense, what I'm trying to say. I opted for that. I'm sticking with that. If you are comfortable, if you are free, and Grub is very popular, so go with it. It's not a big deal. Anyway, the point was that, just to point to, the location could be different. That's what I said this many words to you for this particular variable UEFI boot here. Okay, notify is again lightweight libnotify library, and this is a binary called notify send. Then I hard coded the user local bin. As you see, Dracut is required for if you wanted to run initrd, so it is required to get you the root file system during boot. So you need to make initrd. I rarely need it, so it could be useful for you too. So you can easily comment it out whatever you don't need it, or you can change it, because this script will be available to you at your, you can play with it. I inducted a section where building the kernel, you either opt for GCC or Clang, whatever your choice. The only thing, heads up, is you have to have both the stuff installed in your system, so this script can take advantage of both the stuff. And here I mentioned again, hard coded the stuff in a variable, so it is easily to parse and call up the variable inside the script, which I'll show you. This is a pure fancy stuff. You could outright ignore it, okay, if you want. And then it starts here. It will check the build dir. If it is not there, it will create it. You can see the location from the variable on the top. Then we get into the build dir. Then there is a big function I have written, and all the separate part of the function I'll show you. It is down below. Okay, so I'm going down, a top down approach. Okay, so I'm going down one by one. This is another function I'm calling inside a function, which is basically let me take you there, it will be easier for you. So which kernel is a function. This is the function. You can see I have highlighting. Is a very ordinary function which basically, sorry, I've highlighted. This is the one. This is the one. This is a simple function which will basically, according to your prompt, if you wanted to build the stable kernel, mainline kernel, long-term kernel, if you provide the letter, it will go out in the wild and fetch the version for you from the kernel.org. Okay, the purpose of this function, after you provide the letter or your choice of kernel, which could be stable, mainline, or long term, it will go to kernel.org, fetch the version for you and source it. Simple. Okay, all right, so let me continue then. And then again, eval is a double if you use it outside of a function. I'm following some expert as advice that it mitigate the risk of having eval inside a function. So I'm not going into there, that's a different topic altogether, but this is the way I get it. Okay, these variables are declared top of the script as I shown to you. Okay, the kernel as I shown you recently, the version it will fetch from the kernel.org. You'll pass that with the wget or call, whatever you have assigned to this variable. Then simply it will enter it, and then it will get into the kernel directory. And this is a program, because we are in the Linux source directory, you can, from the top level directory of the Linux source, you can run script var linux. There is a script inside the script which is a top level directory inside the kernel source. Okay, and you call it, it will show you the version. Okay, version of what? Version of different tools inside your machine which are supposed to be required. Okay, it will enlist you along with the version. Okay, so then I simply copy the existing running version of the kernel config to a .config file inside the newly entered kernel source file. Okay, then I again, there is a script called config which will take a parameter enable disable, and which I call, because I'm in the top level directory on the Linux source tree, if you follow along, so it will be called like that. Okay, and I disable specifically the debug kernel info and debug kernel. You could comment it out, because if you turn it off, in some case if you want to run GDB on the kernel binary, it will complain that it won't find any information, because these things are required when you're debugging something on the kernel. If you turn it off, your bets are off, because you won't be able to. There is a way, but that's a long traveled way to get into that. So it depends what are you going to do with your kernel, right? If you're just building a plain kernel, which I do most of the time, because I don't do a lot of stuff inside the kernel, because I don't have the information on, not the capability or knowledge of doing a lot of complicated stuff inside, and so I keep things simple and try to inflate it as simple as possible. Then I simply run the old dev config. These are the pretty standard stuff everybody knows, nothing fancy, nothing new. Okay, then again, this is a function which compiler, which will prompt you either you want it for GCC or you want to do it with the Clang. Okay, on the below line you can see I have just commented out, because it's a generic way of build stuff. I didn't remove it, because you should know how it look like if you do it in a generic way and a simple manner. So this is the way you can build your kernel. Okay, and which compiler is a function I have written down below this script. I'll show you, which will basically prompt you for either GCC or Clang. Now it will notify once it's done, then it will check whether the last command is successful or not. Then it will simply install the module. That installing module is done in that particular function, whatever the compiler you choose. So then I copied the BZ image to the location where it's supposed to be there, and then I enlist what is there in that particular directory. Then I again copy the system map file to the location where they're supposed to be, that boot system map, and then the kernel version, hostname. That's a kind of a weird way of doing, but basically system.map should be there in the boot. And then again there is a config file which I padded up with kernel version and host name for my easy visibility to the stuff where it's supposed to. Why I did it, the reason being very simple. If I look at it something, the name should tell me in the first place what it's supposed to contain before getting into that. So that's a big hurdle for most of the people, like at least ordinary mortal like us. We are inclined to look at the stuff and should get some sort of sense what it should contain. I don't like surprises. I want something to be very explicit. If I look at something, it should tell me it has got something, nothing else. Okay, so that's the purpose. That's why I make it something that which I promptly look at it and it tells me, okay, this thing is that. Next, I just symlink the stuff, because in Slackware it has done this way. So I manually unlink and symlink the stuff which is required. I'm sure this portion can be done much better way. Again, I'm saying, because I did it in this way, it doesn't mean it has to be in that way. This is more explicit and easy to me, so I did it as simple. You could have done in a much more complex or elegant way to accomplish the same thing. Okay, so you feel free to do whatever you like to do, and let me know if you find out a better way. I'm sure there is an elegant way, but this is ugly, but it works for me. So then I try to find a level 1 search to that directory just to see what is there. Then I copied that to the EFI boot directory, which is mounted on EFI boot directory. The EFI partition is getting automatically loaded on EFI boot directory in my system for all the distribution I run. So I have a common boot section, common home section, common data section. They have got a designated mounting point. So they get, while booting the system, they get booted from that designated place to the dedicated mount point. So nothing surprising. I intentionally left this stuff. Again, I'm saying this is a very ugly way, but this worked for me. I just one time and it works. It could have been done in much better way. Again, I am asking you, if you have a clear-cut solution, please do let me know on the comment section so I can adapt it. Okay. And then again, I do the same thing. I just want to deflate what is getting inducted in that file. You can comment out or you can do it silently if you are confident enough. I was looking at the terminal when I wrote this script many years ago, so that's why these things are still there and I haven't moved it. You could have done in a silent way if you are confident enough, so it will take away all the inflation on the terminal. And certainly it will speed up, because the more things you show on while doing this kind of stuff on the terminal, it takes time to get deflated on the terminal. So you probably not noticed it on a faster machine, but you'll certainly notice it on a less powerful machine, which is what I am having. So not only this case, in any other place. This is the function, and this is once this is done, I'm go ahead and remove the build dir where the kernel has been built, because I have already copied the required stuff to the actual main system for main file system. So I don't need this build dir anymore, so I remove it. Okay, and here is the which compiler, where it is prompting you to either select GCC or Clang. And then here is the function to call up GCC compile, a simple steps which you could have manually take while building generic way. So I put it in a function and make it easy to call up one single thing rather than 5 line. That is the purpose of a function, right? If something complex or something takes too much line to type in a thing, put it in a function and call up one line. That makes life easy and looks the script or code much cleaner. So this is a Clang Llvm compile section. Okay, so these two functions get called up when you select one of the keyword G or C. Okay, while building the kernel. This is the function which will, according to your choice, it will go to kernel.org, fetch the number for you, okay, and build according to that, whatever the kernel you choose, whether it's stable, whether it's mainline, whether it's LTS version, long-term version, whatever the way you think. Okay, so this is pretty much it. It's a little lengthy and explicit, probably little ugly and not so tasteful, but it works for me. You are free to change it, and if you make it a good one, beautiful, I appreciate elegant stuff. If you do this, please let me know in the comment section that I could have adapted and changed it. Okay, so this is all you need to build a custom kernel inside. If you are sitting on Slackware, you can adapt this script and build a custom kernel and make the things to work on Slackware. I'm sure there are much better way probably, and I didn't follow it. As I said to you, I wrote this script many years ago, so just one fine evening, and it works for me, so I keep it there. If there is an improvement, there is a better way, or there is an even more integrated way, please do let me know. I would love to see, and I'd love to integrate if something is there. Okay, so I hope this will give you some sort of heads up. And for instance, if I just run it momentarily, because I don't want to run it because it will take so much of time in my slow machine. So I'm inside, sitting inside Emacs. So all I have to do, control C, control X. Look at the bottom of the screen. It is asking me whether I should run the script. If I press enter, see, it open up a stuff, and it is going to build the kernel. Okay, so that's it. I mean, there could be I intentionally didn't show you what are the prompting. Okay, so if you look through the script, it should prompt you, it should let you know what you wanted to. But this is the simplest possible way to build a custom kernel if you are sitting on a Slackware. Okay, so I hope this will give you some sort of information. Thanks for watching.